Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariongi. I welcome you to our today's chemistry lesson. We continue with our topic on acids, bases and salts. Now, today I would like us to discuss the strength of acids and bases. So when you look at the acids and bases, we have some acids that we refer to as strong acids, and we have others that we refer to as weak acids. The same case applies to the bases. We have some bases that are strong bases and others that are weak bases. So we want to find out what do we actually mean when we say that a particular acid is a strong acid. Now, we can say that a strong acid is one that ionizes or dissociates completely in water. A strong acid is one that ionizes or dissociates completely in water. And this strong acid, this complete ionization or this complete dissociation leads to a higher concentration. This leads to a higher concentration of hydrogen ions. In the water. So in other words, we are saying that when a strong acid ionizes in water, there is a higher concentration of hydrogen ions that are released. For instance, we can take an example of hydrochloric acid in solution form. It releases hydrogen ions plus chloride ions. So basically, we can say that this is complete ionization. So hydrochloric acid is a strong acid. Sulfuric acid also completely ionizes to form two hydrogen ions plus sulfate ions. So again, this shows complete ionization, full ionization, complete dissociation. So we are saying that all the hydrogen ions that are there, they are released. Same case applies to nitric 5 acid. Releases all the hydrogen ions. So basically, we can say that hydrochloric acid, sulfuric 6 acid, and nitric 5 acid are strong acids because of the fact that they are showing complete ionization in water, complete dissociation in water. And this leads to a higher concentration of hydrogen ions being released in the water. Let's look at a weak acid. A weak acid is one that partially or incompletely ionizes in water. It shows incomplete ionization in water or incomplete dissociation in water. We have an example, or we have examples for something like carbonic acid. This one, when it ionizes, we get hydrogen ions plus hydrogen carbonate ions. So you can be able to show that this is incomplete ionization. It's only one hydrogen ion that has been released. The other hydrogen ion has not been released. So that is an incomplete ionization. On the other hand, if you take another example of a weak acid, such as ethanoic acid, it also shows the same. So only the last hydrogen ion is released. So we have one hydrogen ion plus ethanoate ions. So, so this is a carbonic acid, which is a weak acid. This is ethanoic acid. Another example of a weak acid. Ionizes partially, only one hydrogen is being released. Then we have these are referred to as ethanoate ions. Ethanoate ions. And here we have hydrogen carbonate ions. So there is partial ionization, or there is incomplete ionization, as we can see from these particular reactions. We have also used the two arrows, the forward and the backward arrow, to show that this reaction is a reversible reaction. It can be reversed. So this is an equation that is a reversible reaction. It can happen in the forward direction, also can happen in the backward direction. So that is as far as the strength of acids is concerned. Let's look at the bases. We talk of a strong base is one that ionizes completely to release hydroxide ions. It ionizes completely to release hydroxide ions, which are the only positive ions. And we have examples such as sodium hydroxide, which gives us sodium ions plus hydroxide ions. So this is a strong base. It ionizes completely to release hydroxide ions. And there is a higher concentration of hydroxide ions that are being released. Potassium hydroxide, we get potassium ions and hydroxide ions. So this is complete ionization. On the other hand, we have some bases that do not ionize completely. So we can say that that is a weak base, is one that ionizes incompletely. It ionizes incompletely to release hydroxide ions. So here we can say that less hydroxide ions are released. As a result of this partial ionization, incomplete ionization, then we have a smaller number of hydroxide ions that are released. So we take an example of ammonium hydroxide solution, what is referred to as aqueous ammonia. Aqueous ammonia is ammonium hydroxide solution, and this one ionizes partially to release ammonium ions, and hydroxide ions. So we can see that there is incomplete dissociation, incomplete separation. So here we have the ammonium radical that is left intact as it is, but there is a release of a few hydroxide ions, and that's what qualifies aqueous ammonia. So you can say G aqueous ammonia, which is basically known as ammonium hydroxide, as one of the examples of the weak bases. Now, we can also mention that to determine the strength of acids and bases, we can either use we can use the electrical conductivity to find out whether a certain acid or a base is a strong or a weak one, or we can use the pH value. We can use the pH value in the pH scale. The first method of using an electrical, by checking the electrical conductivity, we can have a simple circuit having an ammeter so this is a battery with a negative and a positive charge. We have an ammeter to measure the current. We have a switch to complete the circuit, and then we can have the electrodes to bring the current into our solution. So for example, here we can have hydrochloric acid and this is a simple circuit. So you can say in this diagram here is that when the switch is closed, the circuit is completed, and the current flows. So the ammeter records a higher deflection. The ammeter records a higher deflection to show that hydrochloric acid releases more ions. So the more ions are able to carry the electric current, hence a higher deflection, to show that higher concentration of hydrogen ions. So the higher the concentration of the ions, the higher the deflection on the ammeter. The lower the concentration of the ions, the smaller the deflection that we'll show on the on the ammeter. So that shows that if, for example, we are dealing with the weak acids and bases, then we'll only have a small deflection being shown there. But if we have a strong acid or a strong base, based on their electrical conductivity, then we are saying that more ions are being released, and therefore the deflection that will be shown on the ammeter will be more. So we'll see the ammeter deflecting more when there is a strong acid or a strong base. But if it's a weak one, it will show a very small deflection. So at that point, we can have our assignment. So the first question in the assignment, what is a weak acid? 2, explain why aqueous ammonia is referred to as a weak base. And 3, explain why 2 molar, this should be capital, 2 molar hydrochloric acid shows a higher deflection than 2 molar ethanoic acid on an electric circuit. So we are going to stop there until next time. Goodbye.